Hello guys. So welcome to this amazing crash course on building agentic AI application with the help of Langgraph. This entire crash course has been divided into three important parts, and each and every part will be somewhere around 2 to 3 hours of videos, right? And here you can basically see in which way we are going to cover all the topics and where we are going to aim once we reach to the part 3. Okay, so in the part 1 you'll be able to see that we will be covering various fundamental techniques which are really important in order to build agentic AI application. Some of the important topics like how to build a chatbot, how to integrate tools, how to integrate multiple tools in a chatbot, how to add memory, how to add human in the loop, like human feedbacks when you're executing the entire graph state, how to use different streaming technique, how to probably go ahead and use MCP, how to build MCP completely from scratch, right? So this part also will be discussing about. Along with this, there will be various topics like states, what are graphs, nodes, edges, how do you go ahead and use this with the help of graph API, so all these things will be covered in part 1. So part 1 will be approximately around 2 hour 50 minutes maybe. Okay, but I'm just making an approximate suggestion. Along with that, once we complete this, then we go to the part 2. In the part 2, we cover advanced Langgraph concept. Now here, we are going to focus on various kind of workflows and agents. Here is the topic where we will be developing applications where agents will be communicating with other agents, right? And why they will be communicating? To solve a complex workflow. Okay, solve a complex workflow, right? Along with this, we will try to see how we'll be handling the multi-state management even in multi-agents. Then we'll also introduce you to how to directly use functional API instead of just directly going through graph APIs itself. And then I will also be showing you how you can debug and monitor them in the Langgraph Studio. Okay, Langgraph Studio. And for this, we will also be using Langsmith. So this all fundamentals is put up in the advanced part because this will be like one step towards developing some amazing production grade application. And finally, this part 2 will also be somewhere around 2 hours of video. And then we have in part 3 where we'll focus on building completely end-to-end projects. We'll focus on LMOps pipeline. We'll focus on deployment techniques. And recently, I have also explored all the evaluation techniques, metrics, specifically in LLM, and how you can use along with LangGraph and some open source tools, right? Like MLflow, how you can use AWS to track all that kind of metrics. Along with that, how you can use Grafana to probably display all these particular reports. That is where we will be moving in the part 3, right? We'll also be using Hugging Face Spaces to do the deployment. So this is just a tentative plan in order to cover LangGraph crash course. And these all are like long recorded videos. So I definitely require your entire support. Yes, now part 1 is ready. You can go ahead and watch this entire video and make sure that you also download the material from the description and keep on practicing, and definitely do share it in various platforms like LinkedIn and all. I definitely want to see how your learning is. Definitely do tag me in LinkedIn, Twitter, wherever you can, right? So yes, let's go ahead and enjoy this particular session. So guys, now let's go ahead and build a basic chatbot using LangGraph. So this is my entire empty folder. So this will be my project workspace. From this, I will go ahead and open my command prompt. So let's go ahead and open my command prompt. As I said that this is my working directory with respect to my project workspace. I will just go ahead and open my VS Code because I'm going to use VS Code for my coding purpose. Once I open my VS Code, this is how my VS Code looks like. Whenever we go ahead and start any kind of projects or you build any applications, right, it is necessary that you start creating an environment. Most of my videos I've actually shown how to create environments with the help of Conda. But in this particular video, we are going to use something called as UV package manager. Okay. Yes, you can also use Conda. But if you don't know about UV package manager, it is a really fast, extremely fast Python package and project manager, and it is completely written in Rust. Since it is written in Rust, it is very fast. So you can probably compare over here from UV to Poetry to PDM and PipSync. This has the least time. That means that whenever you're trying to create an environment or do any kind of installation of the packages, that happens really, really fast. Okay. Some of the highlights that you can see over here, it is 10 to 100 times faster than pip. It is a single tool to replace pip, pip tools, pipx, poetry, pyenv, twine, virtualenv, and all, right? It provides comprehensive project management and universal log file. It installs and manages different kind of Python versions. Also, you can do it in the same project itself, right? And to start with the installation, if you are in Mac OS or Linux, from the terminal, you just need to go ahead and copy this particular command and execute it. If you are on Windows, go and open your PowerShell, copy this particular command and paste it over there. And if you're using PyPy, just go ahead and write pip install uv. Okay. Once that is done, your the entire project repository will be initialized. Okay. So first of all, what I'm actually going to do is that I'll just go ahead and open my terminal. Now inside this terminal, I'll open my command prompt. I've already done the installation of UV package manager. So I will just go ahead and quickly initialize my project workspace. In order to initialize, all I have to do is that I have to write UV init. Okay, as soon as I write UV init, see what will happen in the project workspace. Okay, so here you can see in the project workspace, there are some files that has got created like .getignore, Python version, main.py, pyproject.2ml. Uh, and if you probably go ahead and see in Python version, which Python version you have actually created, it is nothing but 3.13. Then you also have this main.py so that you can start the program execution directly from here. Then you have this pyproject.2ml wherein you have the project brief information. You can change the version, you can add your own description and all. Here you can see that it is requiring a Python of minimum 3.13. Okay, this dependency is right now empty because we have not installed any kind of packages. Now what I'm actually going to do is that I'm going to go ahead and create my requirement.txt. Now inside my requirement.txt, I will go ahead and install some of the libraries. Let's say Langgraph, LangChain. Then along with this, I will also go ahead and use my Langsmith. Okay. These all are libraries that will be specifically useful. And I'll tell you as we go ahead. Langgraph and LangChain, we are going to use various functionalities in order to build generative AI applications, chatbots, along with that agentic AI applications also. Langsmith is basically used for tracking and evaluation of your applications, directly in the Langgraph cloud. So these are the basic libraries that we are going to use. Now, since I have already initialized this working space, now the next thing is that I need to go ahead and create my virtual environment. So quickly, I will go ahead and write uvvenv. With the help of this command, you will be able to create a virtual environment. This venv is nothing but your virtual environment name. Okay. So once I go ahead and write uvvenv, here you can see that it has got created with the help of this particular version, that is 3.13.2. The virtual environment is at this location .venv over here. Now, in order to activate the environment, I'll just go ahead and copy this quickly. I will paste it over here. Okay. So once I activate this, here you can clearly see that, hey, my environment has got activated. Okay. So here Agentic Langgraph has got activated. Now this is perfect. Till here, everything looks good. Now the next step is that we'll go ahead and do the installation of all the libraries. So in order to do it, like if you're using pip, it is like pip install -r requirement.txt, but here we are going to write uv add -r requirement.txt. Okay. So once you do this installation, here you can quickly see that the installation has been completed. And now if you go ahead and open this particular file, all the libraries that has got installed will be visible over here. Okay. Now, as I said, this is my first tutorial. I'll go ahead and just write one folder name, one, and I'll say, hey, basic chatbot. Okay. And we'll just learn some of the basic stuffs over here. Okay. Now, with respect to this particular basic chatbot, here we are going to go ahead and create our applications. We'll go ahead and create our basic chatbot itself. We'll just go ahead and open my one file. Let's say I'll go ahead and write basic chatbot.ipynb. Okay. So as soon as I open this basic chatbot.ipynb, it will tell me to select a kernel. I will go ahead and select a kernel. And since I'm using Jupyter Notebook for the initial stages, I also have to go ahead and add one more library, uv add ipy kernel. Okay. So follow the steps step by step, like you have to just follow these steps as we go ahead, because ipy kernel will be required in order to run anything in the Jupyter Notebook. Okay. Now, once this is done, I will start writing my code over here. Okay. Now, with respect to the code, let's check whether this is working or not. Okay. it should give an error because 1 plus exclamation is something happening over here. Here you can see it is connecting to the kernel Agentic AI. Okay. So yeah, invalid syntax. Now if I go ahead and write 1 plus 1, it is working fine. Perfect. Now here, as I said, let me just quickly go ahead and write. Here we are going to build a basic chatbot. Okay. Now building a basic chatbot, this chatbot is like a basic chatbot. That basically means, and here whenever I'm talking with respect to Langgraph, okay, with Langgraph, I'll go ahead and write that. Here we are going to use the graph API functionality. Okay. There is one more API which is called as functional API. As we go ahead, we'll also try to learn about it. But what I felt is that the most efficient way of learning Langgraph is specifically using this graph API. Okay. Um, so let's start with this, and let me go ahead and write some information, how you should actually go ahead and start and all the things, and what we are basically going to develop. Okay. So guys, now let's go ahead and build a basic chatbot with the help of Langgraph. Now, before we go ahead, we need to understand some of the important components of Langgraph so that you will be able to understand how to build a basic chatbot. So let's go ahead and talk about the components of Langgraph. There are three important components of Langgraph. Number one, edge. Number two, nodes. And number three, which is called as state, right? Now, what are these, right? What are these components? So in order to explain you, I would like to probably take a use case. Okay, let's say that, and I had this use case a long time and I solved it, you know. As you all know that I also upload a lot of YouTube videos, right? YouTube videos. Now, what I wanted was that as soon as I upload a YouTube video, I should be able to convert or create a blog out of it. Okay, so this is a kind of task that I really wanted to do. Now, in considering this particular task, if we consider this workflow, how this workflow needs to be executed, let's understand this. If I want to solve this task, the first thing is that from my YouTube videos, I have to take out my transcript. Okay, transcript, right? So from these YouTube videos, I want to first of all take out the transcript. Then I will use this transcript, and with the help of this particular transcript, since I need to start writing my blog, I will go ahead and create the title of the blog. Okay. And in third step, I want to take both title and transcript, and we will go ahead and create the content of the blog, right? So if I want to solve this use case, this will be my workflow to solve this use case. First of all, I need to go ahead and take out the transcript from the YouTube video. Then I need to go ahead and based on the transcript, we need to go ahead and generate a title. And then based on the title and transcript, we need to generate a content, right? Now, I am alone uploading the videos, and it is not possible that I also go ahead and create the blog out of it because it will take more of time. But since when like LLMs right now is the buzzword, right? We definitely have LLMs. Now, with respect to LLMs, you know that these are really, really good at content generation. It is very, very good at content generation, right? Now, whenever we talk about content generation, that basically means LLM, it can take an input. Let's say if I say, hey, what is machine learning? It will be able to generate what is exactly machine learning, right? Now, can we use LLM in order to solve this particular workflow with the help of Langgraph? Now, in order to solve this problem, what I will be doing is that I will follow some kind of graph structure, okay? And yes, in Langgraph, if you want to solve this kind of workflows, there are two ways, okay? One is directly using Graph API, and second one is directly by using functional API. But according to my experience, I feel Graph API is the most easiest and most best way. Yes, if you have a lot of expertise with respect to the Graph API, you can directly go ahead and use the functional API. The difference between them, we will get to know as we go ahead, okay? So first of all, what we'll do, in order to solve this complex workflow, I will go ahead and create some kind of graphs, okay? And this graph will show that how my flow of execution will happen. Okay. So let's say that I have this node. I have one more node. Okay. So these are my two nodes. As I said, the components of Langgraph are edges, nodes, and state. Okay. So initially, let's say we are going to go ahead and start over here. Okay. So here I will be having my start node. Okay. In this start node, we give our input, right? Let's say in this particular case, in my use case, obviously I need to give some kind of input. Now, what input I will give? I will give my YouTube URL. Okay. Let's say this is my input, YouTube URL. Then it goes to this phase. From start, it goes to this node. This node should be responsible in taking out the transcript from my YouTube video. So here I can go ahead and write, hey, this is my transcript. Okay, this is my transcript generator. Now, how do I go ahead and generate the transcript? In LangChain, we have some third-party libraries. I think there is something like YT loader, or what it does is that we give our input videos of the YouTube, and output we will be able to get the transcript. So here, output of this particular node should be that we should be able to get a transcript. Okay, now understand one thing over here. So what is this? This is nothing but, this is my node. What is this? This is nothing but, this is my edge, right? So this is nothing but edge. Edge main fundamental is that the flow of information should go from here to here, or node to node, right? So this is also my edge, right? Now, whenever we talk about nodes, right? As soon as you create a node, we also have to create a node implementation, right? Some functionality with respect to this particular node. Like, what does this node actually do? Now, in this particular case, this node functionality should be that it should take a YouTube URL and it should generate a transcript. Okay. And the output of this node should be this transcript. Okay. Now, in my workflow, I have completed this YT video to transcript by that node. Now, based on this transcript, I should be generating the title. So what this node will be doing? This is nothing but this will be title generator. And here the input will be transcript, right? The input will be transcript, and this will be my next node. And this node functionality should be that it should take this transcript and it should generate the title, right? This is what is my functionality. Very simple functionality, right? Now, after this, the output that we are going to give, right, should be my title. Along with the title, I also want to give my transcript. And we go to the next step. What is the next step over here? Which is nothing but content generation. So my third node that you will be able to see over here is nothing but it is content generator. Content generator, right? So this will again be my edge. And this node will have a functionality which will take this information, title and transcript, and it will generate content, right? And finally, you go to the next step, which is end. In the end, you get the output, right? Now see, now you may be thinking, Krish, how do we generate transcript to title? Now, if you have a fundamental idea of LLM, so here in my title generator, I will have an LLM along with one prompt. And then when we give this input of transcript, it should be able to generate the output, right? Similarly, for this content generator, which is the node, if I give the title and transcript, here again I will be having some kind of LLM plus some prompt which will be able to generate the content. Here we give the input as transcript and we get the output over here, right? And finally, all this output is combined and we get display it over here, right? So this is an example of a workflow, and this is entirely with the help of Graph API. We will be able to see the graph, we will be able to see the execution, we'll be able to see the output. Okay. Now coming to this, right? I have told you already about edges and nodes, right? Now, where does state come into existence? Okay. Now see, based on this particular use case, state, we can define something, right? So here, this state will have some values or some variables. We can define some variables, and that variables will, like, that variables can be accessed by any of this node in this particular graph. Okay. So let's say for this particular use case, you know that I require transcript. So I will go ahead and create a transcript variable. As soon as this node is executed, the output will be saved in this variable. Okay. So let me just go ahead and write it down over here. So state means what, right? Whenever we define any kind of state, our main aim is that whatever variables we define over here, right? So let's say one of the variable I want to define is transcript, because as soon as I execute this node, my transcript will get generated, right? And this transcript will also be required in my third node. So what I can do, when I create this state, right? This state will have one variable which will have the information about the transcript maintained. Okay. Similarly, title is my second output that I really want, because here in this node, I want to go ahead and save the title, right? So here title information will be saved. And then here you have content. So let's say that if I go ahead and create these three variables, as soon as we generate those, we can save in this, right? And the advantages of saving that values inside this state will be that inside this entire graph, every node or any of this node will be able to access this variable. Okay. So that is the importance of state. Okay. And this entire graph, we basically say it as state graph. So that is the reason we say it as state graph, because it is able to maintain the context of the state at every node. Yes. Don't get confused with external memory or memory, right? So memory can also be used over here, and that part we'll discuss in the later stages. But here we want to focus more on the state graph. State, it is able to maintain the state within the specific nodes. Now I hope you got a clear idea about the components of LangGraph. Now what we'll do, we will build a basic chatbot. In this basic chatbot, what we'll do, I will be having a start. From this start, I will create one node. Let's say this particular node is nothing but chatbot. And from this, we will go ahead and end it. Now this chatbot will be integrated with some kind of LLM, press prompt. And the work is take the input and give the output, right? So this is the basic chatbot what we are going to build. And as we go ahead, we will go ahead and add tools, external tools. We will go ahead and see that how we can integrate these external tools along with the chatbot. Then as we go ahead, we'll again discuss about React Agent. Okay, so React Agent is something more amazing with respect to the tools. I know there's so many topics that we have discussed, but let's now focus on understanding how to build this basic chatbot. So for this, I will again go back to my code. And now you have understood what is state graph. You have understood what exactly is nodes and what exactly is edges. Okay. Now, step by step, we will go ahead and do this. As usual, what we are going to do is that, first of all, before starting building a chatbot using state graph or graph APIs, first of all, we will go ahead and import some important libraries. Okay. So one important library is something called as from typing import annotated. I'll talk about annotated. What exactly annotated is? It is just to add context specific metadata to a type. Okay. It is better that I show you an example in order to make you understand. One more important library that I'm going to use is typing underscore extension import type date. Okay. Now, along with this, since you know that every graph starts with a start node and ends with an end node. Okay. So for this, I will go ahead and write from langgraph dot graph import state graph, since we need to go ahead and also create a state graph. State graph will be the entire graph, right? Entire graph that you have seen over here. If I want to represent this entire graph, we can represent it with the help of state graph. Okay. And then comma, start, and then we will also have end. Okay. Start and end are just like my start node and end node. Along with this, we will also go ahead and add from Langgraph dot graph dot message import add underscore messages. Okay. Then let's go ahead and execute this. Okay. Now we have imported all the libraries. Now you may be thinking, Krish, what exactly this add underscore messages is? These are called as reducers. Okay. Now what is the importance of reducers? Okay. I will talk about it. Let's say that if I want to create this chatbot, right? If I want to create this chatbot, you know that we also have a state, right? Now, in this state, what is the kind of variable that I really need to create so that any output that is generated by the chatbot will be saved it in one variable itself. So let's say that if I go ahead and create a variable called as messages, inside this messages, can I make this as a list type? And inside this list, as soon as I keep on asking any input, automatically it should keep on getting appended. So again, let me repeat it, what I'm trying to say over here. Let's say if I'm creating this basic chatbot, as soon as I give an input, this should be able to generate an output. But again, in that session, if I give another input, this graph will again get executed and will give me the output, right? So we can execute this graph as many number of times, right? So when we are creating this state graph, okay, state graph. So every conversation, can I save that inside my state, right? Which will be available to this particular node at any point of time. Yes. So for that, what we'll do, we'll create one variable, we'll make it as a list type. And inside this list, we should keep on adding these messages. When I say adding, it should be appending these messages. It should not replace the previous message. Okay. When I say replacing the previous message, let's say in the first instance, I had one message. I said, hi, how are you? Then the chatbot replied, I am good. Then my next question is, hey, tell me what is your name? Then the chatbot replies, hey, I do not have any name. I am just a basic chatbot. So this message should not get replaced. Instead, it should get appended, as every conversation goes ahead, so that we will be able to maintain this information. And that is the reason we say it as state graph. Okay. So in order to probably append it, we can use something called as reducers. Okay. One of the example of the reducers, there are different types of reducers that we can specifically use. One of the reducer is nothing but add underscore messages. Now this add underscore messages, what it is going to do is that its work is only to add the messages instead of replacing in any kind of variable that we define. Okay. So now let me just go ahead and execute this. And now I will go ahead and start creating my state. So here I will write class state is equal to, and here we are going to use this type dictionary. That basically means the state class is going to return type of a dictionary, right? So here, let me just go ahead and provide you some basic doc string so that you should be able to understand it as we go ahead. So here you can see messages have the type list. The add message function in the annotation defines how the state key should be updated. In this case, it appends messages to the list rather than overwriting them. I hope everybody has understood why we are inheriting type dict, because the state is going to return, right? This class is basically going to return of this type. That is nothing but dictionary type, right? So if you see what is type dict, it is a simple type namespace. At runtime, it is equivalent to a plain dictionary. Right? If I'm going and writing class point2d type dict, right? So x is int, y is int, label is str, right? So what we can do, we can provide values in the form of dictionaries, right? Key value pairs like x is equal to 1, y is equal to 2, label is equal to good, right? Something like this. Now, in the next step, what we are going to do is that we create one variable. Let's say messages. Inside these messages, we will go ahead and use annotated. Now, annotated is just like a kind of label. Okay, this annotated class that we have inherited or we are basically writing, it is nothing but it indicates the hypothetical runtime check module. This type is an unsigned integer. Every other consumer of this type can ignore this metadata and treat this type as integer. So if you see some of the examples over here, you should definitely be able to understand. These are something like in Python, what exactly this basically means, right? Now inside this, I will say, hey, you have to go ahead and add the messages inside a list type with the help of add underscore message. So this add underscore message is called as a reducer. Please remember this information. When we say reducer, that basically means it is not going to replace this list with respect to every conversation we have. Instead, it is going to append, right? So here you can see that how this state key should be updated. In this case, it appends messages to the list rather than overwriting them. So this is the basic information, but I will show you how this looks like as we go ahead, because we will go ahead and just display this with respect to the state. Now I will go ahead and build my graph. So in order to build my graph, I'll say graph builder, I'll use the state graph, and I'll give this class, right? I'll give this class. That basically means when I give this specific class over here, this state graph, when we are creating the entire graph, at any point of time, we can provide this specific information to our different nodes. Okay, so this basically becomes my graph builder. Here I'm just going to go ahead and show you my graph builder. It is nothing but it is of a type state graph. Okay, so my state information has got completed. Okay, now in the next step, what we are going to do is that we are going to build our entire graph itself, right? We are going to go ahead and build our entire graph. Okay, now for this, first of all, what we are basically going to do is that I will go ahead and put one more library. So for this, I will use python.env, since we are going to go ahead and use, Grok models. You can use OpenAI models. You can use any kind of model. So here, what I'm actually going to do, I'll go ahead and write uv add -r requirement.txt. So once I go ahead and install this, the installation has been done. Now, once I go over here, right? So here you can see that now we can go ahead and quickly import all the libraries that we want. So I will go ahead and write import OS. Then I will go ahead and write from .env import load_.env, right? And then we're going to go ahead and initialize this load_.env, right? So the reason why we are doing this is that whatever keys we specifically write in our .env, it should be able to load it. So here I'm going to go ahead and create my .env file, right? Now with respect to the .env, the next step that we are going to specifically do is that whatever keys that we specifically want with respect to the Grok API, we'll paste it over here. So this is my env. I hope everybody knows how to create a Grok API key. In order to do that, just go to console.grok. Okay, so here you go to console.grok.com, right? And here you just go ahead and create your API keys. You can go ahead and create your API key, write the API key name, and start using it. Okay, so this API key will be using it, and we can use different models, LLM models, in order to develop your generative AI applications. Okay, so once this is done, I will quickly go ahead and again execute this since my env has got updated. Then we will go ahead and define our LLMs. Right now, in order to define our LLMs, you can do this in two different ways. So first of all, I will show you one very easy way. So I will go ahead and write from LangChain from LangChain underscore grok. Okay, so for this, we need to install this library. It's called a LangChain underscore grok. So I will go ahead and write LangChain grok. Okay, I will open my terminal, requirement.txt. Now here you can see LangChain grok has got installed, and I will go ahead and minimize this. So from LangChain underscore grok, I will be importing chat grok. Okay, so this is one way you can directly initialize the grok model. The other way is more common and generic way, so where you can just give the model name and automatically it should be able to do it. So for that, you will be using from LangChain dot chat models import init chat model, right? So here, if you want to directly go ahead and use your LLM with the chat grok, you can just go ahead and write like this. And with respect to this, you can just provide your model name. Okay, So models, it is up to you. Whatever models you specifically want to use, or you want to go ahead with it, you can definitely go ahead and just use that. Okay. See, at the end of the day, it's all about how you are using some specific models and which model you really want to use. Okay. So here, let's say that I want to go ahead with some other model, right? For this, I will again open my, let's see, my playground is over here. So let's say I will be using some models like llama 3 8,000,000,8192. So here all you have to do is that you have to go ahead and give your model is equal to llama 3 is the name correct, 8b 8192, right? So you can basically give this particular model, and if you execute it, this is nothing but this becomes your LLM, right? This becomes your LLM, right? You can either initialize in this way, or you can also directly go ahead and write something like this. So here I'll be using llama LLM initiate chat model. Here we are going to give the model name. The model name will start with something like this: grok colon llama 3 8 billion 9 sorry 8192. Okay, so here you can use this, and it will also give you the same LLM, right? So these are both ways how you can initialize this. And again, if you are using OpenAI, then you can use langchain underscore OpenAI, and here you can just mention OpenAI colon whatever OpenAI model name you are specifically going to use. Okay, now this is my LLM. So here, if I go back to my graph, right, we have created our LLM. Our LLM is ready. Now we will go ahead and create this chatbot. This chatbot is nothing but it's just like a node, right? Now for every node, you need to create a node definition, right? So in order to create a node definition, I will go ahead and write definition chatbot. Let's say this is my node, and here I'm going to go ahead and define my state colon state. Okay, and here what I'm actually going to do is that I'll go ahead and write return messages colon. Now see this, since this, why I'm returning in this particular variable, because whenever I define this chatbot, right, it should be inheriting the state, because at the end of the day, I need to keep on appending inside this particular variable, right? And the state return type is type dictionary. So that is the reason we are inheriting over here state colon state. And when we write return message colon, here we are going to invoke it with our LLM. So here I'm going to go ahead and write LLM.invoke. And with respect to the invoke, here we're going to use the state of messages. Okay, state of messages. So we are going to basically go ahead and return this. To give you a very brief understanding, this is what is my node functionality is. Okay, this is what is my node functionality. Here we have defined a node called as chatbot. This llm.invoke is basically giving, right, based on this input message. See, this state of messages is what? It will be my input message, right? As soon as we get an input message, we are giving to our chatbot node, and that chatbot node is going to provide the response from my LLM, and it will append inside this messages variable. This messages variable is nothing but it is the same variable that we are defined in the class state. Okay, now this is done. Now in my next step, what we are basically going to do is that we are going to go ahead and quickly start building our graph. So for this, we will be using our graph builder. If you remember, what is graph builder? So graph builder is nothing but it's my state graph. So I will just remove this quickly over here, and I'll just paste it over here itself. Okay, so this is my graph builder, and with respect to the graph builder, how we need to build it, right? In my graph builder, I have to have one chatbot node, one start and one end, right? And there should be edges connected to both of them. And as I told you that we are going to use the graph API, right? So for this, what I'm actually going to do is that I'm quickly going to write graph builder dot add underscore node. Okay, so this will basically be my first node. My first node name will be chatbot. You can mention anything. Let's say I will go ahead and write LLM chatbot. Okay, but the second parameter that I'm going to write is about my node definition. So which is nothing but chatbot, right? So this, every node will have some node implementation. That node implementation, you should be specifying it over here. Okay. Then coming to the next option is that in my graph, right, I definitely have only one node, right? This is the node that is there. But along with this, I will go ahead and create start and end as my starting and end point, right? So in order to create that, we need to go ahead and create edges, right? So first of all, what we are basically going to do is that I'll go ahead and write graph builder dot add underscore edge. So this was my adding node, adding nodes. This is my adding edges, add edges. Now with respect to add edges and add node, here is my start. So from the start, I have to go to my LLM chatbot, right? So from my start, I'm going to the LLM chatbot, and from the LLM chatbot, I should basically go where? To the end, right? So I will go ahead and add one more edge, and this edge is going from LLM chatbot, and remember here you need to specify the node name instead of a node functionality name, right? And this will basically go to my end node. Okay, perfect. Now see, that is what it is matching, right? From start, I have created an edge to chatbot, then again it is going to the end. So this is my entire graph, right? Finally, what we do is that we compile the graph. So these are some of the steps when we define the graph. The compilation is necessary so that we can execute the graph, right? Unless and until the graph is not compiled, you will not be able to execute it, right? So for this, I will go ahead and use graph builder dot compile. And here we are basically going to just go ahead and execute it. Okay. Now the question rises, Krish, can we go ahead and see how this graph looks like? Okay. Yes, obviously you can see it. So for this, we will be using some visualization graph. So I will just go ahead and write visualize the graph. Okay. So from visualization graph, I will go ahead and write from IPython dot display. Okay. Import image comma display. Okay. So we are going to use this. And again, we're going to go ahead and use try catch block, where we're going to use this display method, which is responsible in displaying the graph with respect to any image object that you give. And if I go ahead and write graph.getGraph, I should be able to get the graph itself. And this we will try to draw it in some mermaid PNG. Okay. These are some of the functionalities that were provided over there in the documentation. So I'll go ahead and write except exception. Okay. And here I can just go ahead and write pass. So here you can see this is how my chatbot looks like. So here I have start, this is my LLM chatbot, and this is my end, right? So when I give my input from here, my LLM, my start will be sending this, and I should be able to get this. Okay. Now the time is that how do we run this? You know, we really need to run this, right? At any point of time. And if you are running it, how does it basically looks like, you know? So for this, I can directly use this graph dot invoke. Okay. And I will say, hey, hi. So let's say this is the message that I'm giving. So what will happen? Hi will go from here. It'll go to the LLM chatbot. It'll give you the output and it'll end. That's it, right? So when I say hi, got hi. Okay. So one problem over here that you'll be able to see that when it is trying to retrieve the details, there we are facing some kind of problems. Okay. Now, what is the exact problem that we are facing? I will just try to resolve this as we go ahead, you know. So let's go ahead and do this. So here, one very important thing is that in the state, you remember that what is the variable that we created, right? Messages. So what I will do, I will go ahead and create a dictionary called as messages. And now inside this, I will give my message saying as hi. Before I had not given this, so it is not able to pick it up, right? Because here, if you see inside my functionality of LLM chatbot, it is invoking from this particular variable, right? From state of messages where it is basically saved, right? So here, now let's go ahead and execute this. Now it should execute it. Let's see. Invalid API key during the task. Okay. So my env is ready. Okay, no worries. See, the problem over here is that we need to restart the kernel because my API key, I added it in the later stages, right? So that is the reason. So quickly, I will execute all these things. Sorry, graph builder is not required over here. Now it should execute it because I just needed to reload this, you know, by restarting my kernel. Then only it will get reloaded. Okay, no worries. Now it should work. So my visualization graph is there. And now I'm invoking the messages of hi. Now here you can see that I have got graph.invoke messages of hi Human message. Now see, this hi that is going, right, it is being treated as a human message. And now your response is with respect to the AI message. Hi, it's nice to meet you. So let's go ahead and save this as my response. Okay. Now, in order to check the response, right, what was the final response here? You can see that I can go ahead and read inside my messages variable. Now, this is what is really important. See, inside my class state, right, I told you that we are going to create a variable, right, over here. This is my messages variable. Annotated was there, list was there, and add message was there. This add messages is acting as a reducer. Reducer work is to append inside this list. See, initially human gave hi, then AI message gave hi, right? And this is got added inside this list. Understand one very, very important thing. And this is in the messages variable, right? Now you may be thinking, Krish, what is this annotated? Annotated basically means what? As soon as I gave hi, see over here, automatically this message is got converted to human message, right? Human message is just like one kind of annotation. We the graph is making sure that it is annotating and it is appending in this specific list. And the reason it is getting appended, because here you can see that directly that my messages are getting appended with the help of those reducers itself, add underscore messages itself, right? Now, I hope you are able to understand it, right? Why we have specifically defined it. Now, the question rises, how do I go ahead and retrieve the last message? It is nothing but response of message -1. Okay, so here you can see that I have got this. And if you just go ahead and write dot content, you should be able to get, hi, it's nice to meet you. Is there something I can help you with? Okay, so this is the most easiest way of probably reading all these stuffs. Okay, now there are two more way of streaming it, right? Streaming your specific data, or running your entire graph, and displaying the information, right? So that is what we will discuss now. And understand one thing, guys, if you are able to understand this, right, trust me, as you go ahead, any kind of graph, any kind of complex workflow that you have in your mind, you should be able to execute it. Okay, now what I will do, I will go ahead and write for event in graph dot stream. Okay, so this time, instead of directly using graph dot invoke, I am using something called as graph dot stream. We will understand about this as we go ahead, but I just want to give you some kind of information how things work in this. So now here I will give you messages. Okay, and colon, let's say here I go ahead and give hi, how are you? Okay, so this is what is my message. Let's see whether everything looks fine. Yeah, this is my for loop. Yeah, now what I'm actually going to do, I will just go ahead and write print event. Okay, now let's execute this. So here you can see that inside this I have got an output which looks something like this: AI messages, AI message, all this information, and I'm getting this, right? Now when I am doing graph.stream with this particular input, right? So here I'm getting with LLM chat. LLM chat is nothing but my node which you are able to see this. Okay, now let's say that I will go ahead and write one more for loop. I'll write for event, or so for value in event dot values, event dot values. Now what will happen if I just go ahead and print this? Okay, see, I will print my value. Now if I execute this, here you can see that I'm getting this AI message, right? So that basically means now whenever we try to stream from this graph.stream, and whenever we try to see the event values, only AI messages will be getting displayed, right? Now in order to display this, what I can basically do is that I can also go ahead and write value of messages, which will be my last message -1. And here I'll just use dot content, and this will basically display the same thing like what it was displayed over here, right? Hi, I'm just language model, so I don't have feelings or like human do and all. This is just one specific example I've told about streaming, but don't worry, because this streaming, we will discuss more about it. There are multiple types of streaming. With respect to streamings, you can also provide different parameters, what exactly it means, so we will discuss about it as we go ahead. But here, this was just an example of how you can go ahead and build a basic chatbot. Okay, now it's time that we start thinking, Krish, can we go ahead and integrate some kind of external tools? Okay, so for this, let me go ahead and talk about a use case. Let's say I have a chatbot. Okay. Now this chatbot, I have a question. I can basically go ahead and ask a question for this chatbot saying that, hey, let's say this chatbot I have. And this chatbot, what does it have? It basically has a LLM with some kind of prompt, and it is taking an input from the start and it is basically ending it, right? So here, start, end. Now, if I ask a question, provide me the recent AI news. Do you think this chatbot, with the help of this LLM, will be able to provide the output? The answer is simple no. It is not able to provide it. Why? Because LLM will not have any information related to live, right? Any live information it will not have. It may have not trained with the recent data, right? So here the dependency on external tool comes, right? External tools comes, right? So what we can basically do is that for this chatbot, as soon as we give an input, this chatbot should understand, hey, we are not able to answer it. So I definitely have to make a tool call. I definitely have to make a tool call. And when I'm making this specific tool call, this tool call, let's say this can be any third party API, it can be Google search engine, it can be, let's say, one of the search engine that we are going to use is Tavily. Tavily is nothing but it is a web search. It provides a web search API. Okay. And with respect to this Tavily, we will be able to get some kind of response over here. Okay. So as soon as we make a tool call, or in order to define it like this, I will just make this graph a little bit longer now. Okay. So what happens as soon as I get an input? The next thing is that the chatbot is understanding it is a tool call. So it goes and makes a tool call. And here we will define another node, which will be called as tool node. Okay. And then based on this tool call, I should be able to get the response in the end. Okay. So instead of chatbot not able to give you the output, let's say if I give any input, provide me the recent AI news, this request will go to the chatbot. Chatbot will understand, hey, we do not have that information, so definitely I have to make a tool call. So here what it will do, it will make a tool call, and then from here it will go to end. Okay, it will go to end, right? And here in this tool node, I may have multiple tools. I may have tools like Tavily. I may also go ahead and define some custom tools. Let's say add, subtract, or some custom implementation also you can go ahead and write. Right? Now the question rises, how does this chatbot knows about the tool node? See, there is something called as LLM. Okay. Inside this chatbot, we use LLM, right? LLM is actually the brain behind taking this decision. Why? This LLM can be binded with these tools. When LLM is binding with these tools, what does this basically mean? Here it means that, let's say I go ahead and create one custom function. This custom function is called as addition. Let's say this is my addition. This can be added as a tool to the LLM. It can be binded with LLM itself. Then the LLM here, whenever you define any custom tool, you also need to provide the doc string. You need to provide the doc string. Now, with the help of this doc string, the LLM will know what are the inputs and what are the arguments that is required over here. So if this inputs and arguments matches with the input that we are giving in this chatbot, then automatically this is going to make that particular tool call. Right? So this same thing, I will try to show you it in the practical way. We will go ahead and create some tools. We will also go ahead and create some of the custom tools. And once we do that, what we are basically going to do is that we are also going to go ahead and create tool node. And there is one more additional condition, which is called as tool condition. So we will discuss about all these things with respect to this particular implementation. But our main point over here is that the chatbots can also be integrated with a separate tool node. And here it can also make a tool call based on a specific input that we get. Okay. How that can be implemented? By binding tools with the LLM, and also defining your custom functions if it is required. And this LLM will be able to understand whether it has any tool or not through these doc strings. Okay. So now let's go ahead and implement those functionality. So guys, now let's go ahead and start building a chatbot with tools with the help of LangGraph. Now, first of all, I'll just show you like what we are trying to build over here. Okay. So here is one graph, which we will try to create. Now just observe this graph. Okay. This graph is quite amazing because here we have a separate set of tools. Okay. Here we have a tool calling LLM. Okay. So from here, we are definitely going to give our input. Now from this input, as you know, these are my edges. This tool calling LLM is my first node. And this node has LLM with binding tools. Okay. When I say binding tools, what does this basically mean? So this means that I have LLMs and tools integrated with themselves. We will use a couple of tools. One of the most famous tool that we will try to use, let's say we will use Tavily API or Tavily search. This is just like an internet search. Along with this, we'll also create some of our custom functions. Okay. We will create some of the custom functions or custom tools. Okay. Tools. And remember here, when I can also combine multiple tools in one tool node. Okay. So here, what we are doing is that we are going to combine this in one tool node. Okay. So this is nothing but this is a tool node. And here you can observe one more very amazing thing, right? So from this particular tool, from this particular node, here we have two paths. Either we can go there, here, or either we can go over here. So let's say if my question is, hey, what is the recent AI news? So the input will go over here. Then this tool calling LLM will decide whether it can give the answer or whether it is dependent on some tools. Since we have binded these tools, and remember how LLM will be able to understand from the doc string, right? So in every tool, there is some kind of doc string. Doc string is nothing but some brief information about what that tool actually does. Okay, I will also define one custom and show it to you. Then this tool calling LLM, since it has those tool information, it will take a decision whether it has to make a tool call or whether it can just answer it and go to end. Let's say if it makes a tool call, the tool will then provide some kind of output message and it will end. If it is not a tool call, it is just going to go and give you the output and go to the end state. Okay. So this is fundamentally a simple problem things that we are going to solve right now. Okay. And we'll solve it step by step. Okay. How do we go ahead and solve it? That I will discuss as we go ahead. Okay. So now let me go back to my code. So first of all, in my requirement.txt, I will go ahead and import one library, which is called as langchain underscore Tavily. Okay. Now langchain underscore Tavily is nothing but, if you see in my .env, right now, I don't have a Tavily API. We need a Tavily API. Okay. And in my requirement.txt, we need to first of all install this. So quickly, let's go ahead and open my terminal. And here I will go ahead and write uv add -r requirement.txt. Okay. So once we do the installation will be completed and we are good. We have this langchain Tavily. The next step will be that I will just go ahead and open this website we called as Tavily. Okay. So here you can just go ahead and search for tavily.com. It empowers your AI application with real-time accurate search results tailored for LLM and RAG. It's just like an internet search. Okay. So I will just go ahead and log in. Once I log in, here you can see that it will give you one key. I will copy this key and it is free for free. You can probably hit many number of requests with the help of this. So I think you don't have to be dependent on my API key, right? So I will go ahead and write Tavily underscore API key and I'll paste it over here, right? Now, the next thing is that since I'm working over here with the help of this, I will just go ahead and restart my kernel. Okay. You have to restart your kernel, otherwise things will not work. The reason is very simple, because we need to import this again. So I will first of all go ahead and execute this. This will basically be my LLM. Okay. This can be your LLM, no worries. Okay. Now I'll go back over here. Now let me go ahead and import some of the libraries, right? So for Tavily, First of all, I will go ahead and import this tool. So I'll write from langchain underscore tably. Okay. I'm going to go ahead and import tably search. Okay. I will go ahead and create this tool wherein I initialize the tably search. And here my max underscore results is equal to 2. Okay. And then I will define my tools. Let's say this will be my list of tools. Okay. I can still define many number of tools I like. Okay. But I'll use this tool. Let's say I will go ahead and just invoke with one message. Let's say I will write what is Langgraph. Okay. So this will basically be my question. Now, once I execute this, here you should be able to see some kind of response. So here you can see what is Langgraph results. You are able to see all these values, title from different source and URL. You are able to see this, right? Langgraph is a Python library, and all this information is specifically coming up. So once we have created this Tably search tool, now our next step will be that we will just go ahead and try to create our custom method, okay, custom function. So that gives you an idea like how you can also integrate a custom function and how LLM is able to understand, because I spoke about something called as docstring, right? So how do we write this docstring? Everything we'll discuss, right? So let's take a basic function. So here I will define one custom function. And this custom function here, we're going to just go ahead and write definition multiply. And let's say here, I will go ahead and write A int, B colon int. And let's say this is going to return type of int, right? So now the question rises, how do we go ahead and write our document string? So this basically gives you a document string example, okay? Here in the summary, let's say I will go ahead and write multiply A and B, okay? And then here, let's say A will be my first int, B will be my second int, and it returns an output int, right? So it is something like this. I've just written some information. Now, this is what is called as docstring, okay? Now, this docstring will be very important because once we bind any functions, right, with our LLM, or these functions can also be converted as a tools and bind it, right? And then LLM will be able to understand what this tool will be able to do it. Now, what I will do, I will go ahead and create my variable tools. Here, I'm going to use first tool, comma, multiply. And let me just go ahead and execute it, right? Now, as I told you that I need to bind this entire tools, this list of tools with my LLM. So I will go ahead and write LLM dot bind underscore tools. And here we're going to basically go ahead and write tools. And this will be nothing but LLM with tools. So once I go ahead and write, so here now, if you go ahead and see, this is nothing but LLM with tool, right? So this is nothing but it is a runnable binding chat grok. It has all the information over here. And what all functions it is basically connected to, like it is connected to Tably search, it is connected to multiply. You can find out all those specific information over here itself, right? And this is how things work in this. Now, once we have defined this LLM with tool, this tool we are going to use inside our chatbot node, okay? So now let's go ahead and create the entire state graph, right? Remember the structure of the state graph, how it will be. I have start, I have tool calling LLM. This is connected to tools and this is end. Okay. Now our question is that how do we basically create this tool nodes also? And for this also we have some predefined packages available in Langgraph. Okay. So I will quickly go ahead and write from Langgraph dot graph. As usual, I'm going to go ahead and import state graph. See, again, I'm importing all these things so that you get to know, like, I know in the top already we have imported it, but you should know what all things are there. So from langgraph dot prebuild, I'm going to go ahead and import tool node, right? See, we have anyhow binded this LLM with all these specific tools, right? So binding will play a very important role. See, there are two important things. One is binding. When we are binding LLM with tools, this actually helps the LLM to understand which all tools it has, right? So whenever an input comes, it's just imagine LLM has some kind of weapons to solve your input, right? If I ask, hey, provide me the recent AI news, obviously LLM will not be able to do it. It will do an internet search and it will try to provide you the response, right? When we do this binding, it is just trying to give you an information that LLM has all these specific tools. But further, when an LLM makes a tool call, it has to make a call to this tool. That is what we really need to understand how that tool call will be happening. Okay. So I'll go back over here. We have imported something called as tool node. Now, all the tools that we have created, these all tools, it has some kind of functionalities, right? These needs to get converted into a tool node. Okay. Because each tool node will be having some kind of implementation. Along with this, we will also go ahead and import one more library from langgraph.prebuild import tools condition. Okay. Now, first of all, we will go ahead and start with the node definition. Okay. Here we are going to create a definition. Okay. And before creating a node definition, also, first let's start creating the graph. Okay. So, first of all, we are going to use a builder. This will be of type state graph. And inside this state graph, we will be using something called as state. Okay. This will be our class, specifically state class. Then in the next step is that we are going to go ahead and create our builder.add node. So two nodes we definitely require. If you see in this graph, one is the tool calling LLM and one is the tools, right? So first we will go ahead and create this node. Inside this node, we will give the name as tool calling LLM, okay, comma, and then I have something called as tool. I have to define the functionality of this node, right? So this in the later stages will define. Still I have not defined because I will be defining it over here. The other edge that we really need to create or other node that we need to create is nothing but add node is nothing but tools. And remember, this tools will be nothing but it will be of node type of tool. And here we are going to give all our tools itself. So this node is nothing but it is this specific nodes. And inside this node, if I want to go ahead and write a definition, it will be of tool nodes. If you go ahead and see the definition of this tool nodes, it is how all the list of tools that we specify, it will be implemented as a tool node itself. Okay. So this is my node name and this is the definition. This is my node name and this is the definition. Now let's go ahead and create the definition. So for creating the definition, I'll go ahead and write tool underscore calling underscore LLM. And here we are going to define state colon state. And here we are going to go ahead and write return messages colon. Again, what we are going to go ahead and write here, we are not directly going to call LLM, but instead we are going to call LLM with tool, right? So here LLM will tool dot invoke, and where do we get the input from? From state of messages, right? So here we are going to go ahead and define state of messages. Perfect. So here you can see very clear. Now in the next step, we are going to go ahead and add the edges. Now adding the edges is really important. If you understand this, any kind of complex use cases, you'll be able to understand it. Okay. So the first edge is from start to tool calling LLM. Okay. So first of all, let's create that. In order to create it, we will just go ahead and write something like this. See, builder.add edge start to tool calling LLM. Now from tool calling LLM, there are two nodes that are going on, right? Sorry, two edges. One edge is going to the end and one edge is going to the tools, right? Now this kind of edges are called as conditional edges. Okay. So in order to add a conditional edges, it will be like builder dot add conditional edges. And inside this, we are going to call our tool calling LLM. From tool calling LLM, this will happen, right? From this specific node, it is going to happen. So tool calling LLM. And in the next, this is really important. Okay. In the next, we are going to import something called as tools condition. Now the question rises, Krish, what is this tool condition? Tool condition applies two different kind of conditions. One is, let me go ahead and write it over here. If the latest message, right? in the input message when we are giving from the assistant, if the latest message from the assistant is a tool call, then tool condition routes to tool node. So tool node is basically created over here, right? If you create with this other name, this will not happen then. Okay, so that is the reason we have created this tools node. Okay, if the assistant is saying it is not a tool call, then it will go to the end. That basically means this will serve and it will go to the end. So this tool condition basically applies two different conditions. If the latest message from assistant is a tool call, tool condition routes to tool. If the latest message from the assistant is not a tool call, tool condition routes to end. And that is where you are actually doing this with the help of tool condition. Okay, very simple. Here, if this tool calling LLM is making a tool call, it will go to the tool node. Otherwise, it will go to the end node. That is what tool condition does. Okay. And that is the kind of, see, whenever there are two edges coming from a node, it has to go inside this additional conditional edges, add conditional edges. Okay. Now, finally, I will go ahead and add the final edge, builder dot add edge. And you know where this add edge should go, right? The final edge will be nothing but it will be from tools to end, right? The other part, sorry, this is a keyword. So other part is that by default, if it is not a tool call, it is anyhow going to go to the end. Okay, so this is actually managing the other condition. Now finally, we will go ahead and compile the graph. Compile the graph. After compiling it, let's go ahead and write it out. Graph is equal to builder.compile, right? And then we are going to go ahead and view the graph. Okay, so for viewing the graph, it will be nothing but use that same function called as display. And here we go. State is not defined. Okay, state is not defined. Let me go ahead and again, I think I restarted the kernel, right? So that is the reason we got that issue. So I will just go ahead and execute this. Okay, and this two thing I'll execute it. Perfect. Now this should definitely work. So here you can see that I'm getting one error, node already present. The thing is that I did not define the node definition over here. Okay, so let's go ahead and define this and execute it. Okay. Image is not defined because I need to import the image library. It's okay. No worries. I will do that. Okay. Now here you can see I've got the same image, start, tool calling LLM, tools and end. Okay. Now it's time we see that how we can probably call this. Okay, quickly. So I'll go ahead and write messages is equal to, or I'll just go ahead and use that same graph dot invoke. So we know there is an invoke method. And here we will go ahead and give our messages parameter and I will give my message. Hey, I'll say, hey, what is the recent AI news, right? Now, with respect to this, you know, if I'm executing this, right, it definitely needs to make a tool call to my, you know, to the third-party API with respect to Tavily. Now here you can see, this is lovely. See, clearly you are able to see what is the recent AI news. So here is the human message that has got appended. In the AI message, it did not respond anything. The content is empty, but it is saying that the LLM has made a tool call, right? Tool call. The ID is this, the function name is this, and this is the query, right? With this particular topic news, right? And here you are able to see this. And finally, the tool message that you are getting, recent AI news, follow-up questions, all this information that you are able to see. Okay. Now we need to see what information it is able to see, right? So now I will just quickly save this in some kind of response. Okay, response. I'll execute this. Let's go ahead and write this response. So this response is basically coming like this. I will go ahead and see my messages. I will take the last message. It should definitely be a tool call. So tool message. And if I just go ahead and write dot content, I should be able to do this. Recent AI news was the query. Follow-up question is null. And this is all the information. NVIDIA self-driving software platform, all this news information is specifically coming. If you want to display it in a much more better way, I can also go ahead and write something like this. For M in, let's say, whatever response I'm getting, response of messages. Okay, response of messages. From this, I'm just going to go ahead and write m dot pretty print. Okay, pretty print. I know. So here you can see what is the recent AI news. It made a tool call of Tably search, and here is my query with respect to all the response that I'm able to get. Right now, the question rises, Krish, did we go ahead and test some other things? So let's test one more thing. One more tool we added, right? What is 2 multiplied by 3 or the multiply function? What is 2 multiplied by 3, right? And we will try to display the same response over here. This time it will make another tool call, okay? And that tool call will be nothing but it will be a multiply tool call. See, multiply tool call. Now, how it is able to do it? Because LLM has that binding information already, right? And it is able to make this specific tool call in a much more easy way. But still, there is one very important thing. See, tool message is coming up something, but the operation is not happening, right? Why it is not happening? See, over here, you can see that what is 2 multiplied by 3, or I'll just go ahead and ask what is 5 multiplied by 2. If I'm executing this, okay. So here you will be able to see that 5 multiplied by 2, it is not probably producing the right kind of output. So one interesting thing you could see, guys, so over here, when I'm multiplying here, the output is null, right? Then I got to see that there was some mistakes that we did. We did not go ahead and write the definition. So return a multiplied by b. Okay, so now I'll execute this. This will be basically be my tools, tool LM binding tools. So this will be my LLM tool. Now, let's see. I think now it should get executed. So 5 multiplied by 2. Okay, still I have to go ahead and recompile my graph. Okay, so I'll go ahead and recompile my graph. Now, if I just go ahead and execute it, let's see, it'll come. So now you can see tool call has made 5 comma 2 argument it is able to find out, and tool message is nothing but name multiply and answer is 10. So this kind of issues, smaller issues may come, but you need to go ahead and fix it. Okay. But now one more important thing is that what if I just go ahead and write something like this? Okay. See this. Okay. What is 5 multiplied by 2 and then add 10? Okay. Or let's say I'll go ahead and say then multiply 10. Okay. If I go ahead and execute this, here you'll be able to see some kind of messages. Let's see. So here you can see first what is 2 multiplied by 2 and then multiply by 10. So multiply 5 to 10 to, okay. It is able to capture the argument. It is able to find out this multiply, and here also we are able to get it, right? So what is 5 multiplied by 2 and then multiply by 10? It is able to find it out. Okay. Now see, I will again change this. This is also working. Give me the recent AI news and then multiply 5 by 10. Now, if I execute this with this kind of query, now just think over it, what is going to happen? So here, one very important thing happened, right? Give me the recent AI news. In this particular sentence, there are two important sentence itself. One is the give me the recent AI news and then multiply 5 by 10. With respect to the give me the recent AI news and then multiply, here you can see Tavli search is done. But after that, it gave the output and it came out. But what about this particular query, right? Now, what has actually happened? See, if this is my LLM, okay, this is my LLM or this is my chatbot, let's say. Here I asked question, what is the recent AI news? What is the recent AI news? And I asked multiply 5 by 2. Let's say I asked this 2 question. So in a sentence, there are 2 questions, right? LLM, as soon as it got the input, it made a tool call. The tool call was in a tool node. Why it make a tool call? Because here you can see that it is asking for the recent AI news. And it knows that in the tool call, it has Tavli API. Okay, Tavli. And then from here, it went to the end node, right? This was start, this was end. But what about this particular question? Multiplied 5 by 2, right? And this is how was my entire graph. Don't you think if we made some kind of changes, then this answer will also be able to come. Now, what was the changes? Here, instead of once the tool node gives you the output, can't we give that output back to an LLM instead of sending this output to the end state? Now, once we make this response back to the LLM, then the LLM will be the main decision maker. And this decision maker will help them to probably take up the next query, multiply 5 by 2. And then it can again make a tool call, because here I have my multiply function also. And then once it gets the response, it will give it back to the LLM and it will combine both the output and give it till the end of the output, give it at the end of the output. So this way of interaction of LLM with tools, right? It specifically uses a very important kind of, you know, that there is a very good communication that happens between LLM and tools, and we use a kind of agent which is called as the React agent. Okay, and this React agents plays a very important role altogether, right? Now, first of all, what exactly is this React agent? You need to understand. Okay, let me just go ahead and explain this in a better, simpler example. Here, I definitely have an LLM. Okay, let's say this is my LLM. I ask a question, okay, and you know that this LLM is nothing but it is the brain, right? So here it is the brain, right? When I say brain, this will be responsible in making the decision which tools to call. And in the LLM, I have some kind of binding tools. So here we go ahead and start. Here we go ahead and end, right? And here is my tools node. This is my another node. Okay. So let's say here I give my natural input. The natural input is that provide me the recent AI news. And along with this sentence, I say, hey, multiply 5 by 5. Now LLM, when it takes this specific input, it breaks this into two sentences. So first it will try to serve this AI news. As I said, this is the brain, right? So what it does, it knows it has to make a call to the tool node. Now with respect to the tool node, it will get an output, and instead of giving to the end, what it will do, it will come give the response to the LLM. Now the LLM will still have the second sentence context. Then what it will do, it will again make a tool call node. Why? Because this is 5 multiplied by 5, right? So multiply is again there. It will again go ahead and hit this particular tool node and again get the response. Then it will go ahead and see, hey, is there anything left in this particular sentence? Nothing is there. So what it is going to do, it is going to summarize and give you the output at the end. So this way of communication, right? This agent architecture is basically called as React agent architecture. In React, there are three main key terms. One is act, second one is observe, and third one is something called as reason. Act basically means whenever an input comes, the LLM will be able to make a tool call, right? Then when the output of the tool comes, the LLM will observe. Okay? The LLM will observe. Do I again need to make the tool call or should I directly go to the end? Let's say if this is a question again coming after that, then again it makes a tool call. Okay? And then again it is going to get the output. Reason basically means after it gets the output, what the LLM should do, that LLM is making the decision, right? And this is where your agent architecture comes into existence. That is where your agent behavior comes into existence. And this was the rise. Because of this, now agentic AI has become very much popular. Okay, that is the reason why it has become really, really popular. So in order to just implement this, see, I will just give you an example. So here, if I want to go ahead and just use this React agent architecture, okay, how we are basically going to do this? Okay, I will just go ahead and use the same thing. See, I will use this same state graph. This agent, now you should tell me where the changes should happen. Okay, I will copy this over here. From the tools, instead of going back to the end, it should go back to tool calling LLM. Yes or no? Just think. Instead of going from tools to the end, it is now going to the tool calling LLM. Now, how my diagram will look like? This is how it looks like. From start, tool calling LLM, goes to the tool and again goes back to the tool calling LLM. And this can keep on repeating unless and until the answer is completely satisfied and the LLM is basically making the decision. Now, if I go ahead and ask this question, now see the magic, okay? See the magic, how good the output will come, okay? So here, if I go ahead and probably just show you the output, give me the recent AI news and then multiply 5 by 10. Now see LLM, how it is going to behave. So give me the recent AI news, multiply by this, query, tably search, it is happening. Perfect. Here's the recent AI news. After this, what has happened? The response has gone back to the LLM. And then now multiply 5 by 10, which is nothing but 5 multiplied by 10, which is 50. And this is how your entire React agent works, right? And I hope you're able to understand this with this beautiful example that I've considered over here, right? And this is with respect to the React agent. So I hope you are able to understand this. Now you can keep on adding any number of tools. The LLM will be the deciding factor which tool to specifically call. So guys, now we are going to go ahead and implement about adding memory in the agentic graph. So whenever you create a graph, Langgraph has a feature wherein you can go ahead and add memory. And this memory actually solves a major problem, that is nothing but persistent checkpointing. Now, why do we specifically use this memory? Okay, so let me just give you some examples. So already if you know that we were able to invoke it from the previous graph that we have actually created. Now let's say that I will go ahead and ask a question. Hello, my name is Krish. Okay, so let's say this is what I'm communicating with my chatbot. So my chatbot should be able to give me a good answer, right? It is going through this entire graph. Over here, the tool call is not required. So directly it is going to the end after giving the answer, right? So let's say that here I've just asked, hello, my name is Krish, and it is able to probably provide a nice response saying that, nice to meet you, Krish. How are you today? Now what I will do, I will again go ahead and ask a question. What is my name? Okay. What is my name? What is my name? So now what it is basically going to happen is that, you see, like what kind of response we will be able to get it over here. Now, what is my name? It is making this tool call. I apologize for the mistake earlier since the tool ID yielded. I will assume you're asking about your name again. Unfortunately, I don't have any information about your name and it's not provided in the conversation. Can you provide more context or clarity what you mean by name and all? So see, I just now told, hey, my name is Krish. And it also told me that, hey, nice to meet you. How are you today? And now when I'm asking the same question, what is my name? It does not know. So it is not persisting that entire information with respect to the previous conversation or previous interaction that we had. Now, Langgraph has a very special property in order to overcome this advantage, which is called as memory. Now, for memory, what we will do is that we will, let's say that I'm going to use the same graph. Okay, so I will copy this and let's say I go ahead and paste it over here. Okay. Now, once I paste it over here, Langgraph has a feature wherein you can create a memory saver checkpoint. Okay. Now, how do I go ahead and create it? So here, what I will do, I will just go ahead and write from Langgraph dot checkpointer dot memory. Okay. And here we are Langgraph dot checkpointer dot memory. We are going to go ahead and import. So let's see whether the spelling is correct. Checkpointer dot memory. So let me just go ahead and use this. And here you can see from Langgraph dot checkpoint dot memory, import memory saver, and we go ahead and initialize this memory saver. Now, what this exactly memory saver is, it is nothing but it is an in-memory checkpoint saver. This checkpoint save stores checkpoints in memory using a default dictionary. Okay, so here if you go ahead and see that, what it is going to do is that with respect to every node that it executes, it is just going to go ahead and save all the information so that you can recall this particular memory again and again whenever it is required based on the previous interaction. Okay, now where do we add this specific memory? This is really important. So here we have created a memory object. Where do we add it? While we are compiling, there is a parameter which is called as checkpoint. We have to add this memory over here, right? So once I go ahead and execute this now you can see that I have this exact right thing. Now what I'll do, I will just go ahead and give some input. Okay. Now see, if I want to use this specific memory, right, for a previous interaction, or probably I want the context of the previous interaction, first of all, we need to go ahead and create a thread ID. This thread ID will be important because it will be related to one specific session. So we will go ahead and create a variable. Let's say I will just go ahead and create a variable. So this is memory, obviously. Okay. And now I will just go ahead and create one config. Okay. Inside this config, we will be using a key which will be called as configurable. And inside this configurable, we are going to create one thread. And this thread, any ID or any number that I'm giving, it should be unique. Let's say I'm going to probably a user has joined a session. So I will go ahead and make a thread for that particular user. Okay. And this is the configuration that we need to give, right? Configurable key, and there should be a thread with this particular key value pair, right? And this should be unique. So once I have provided my unique thread ID, now what I'm actually going to do is that I'm going to use this graph and I'm going to call the invoke method. Okay. Now, once I call the invoke method here, I'm going to basically give it in the form of keys, right? Dictionary pairs. So here I'm going to basically go ahead and write messages. And now if I give the message saying that, hi, my name is Krish. Now see what will be the magic that will happen. Okay. So here, apart from this, right, the messages that we are giving, we also have to make sure that for which thread ID I am providing the configuration. So here there will be one more additional parameter which is called as config, and we will provide this particular config, right? So once we get the response, I will just go ahead and print this response. So this will be graph. Let's go ahead and print it. Okay, response. Perfect. Now I should be able to get my output. So here you can see that output is nothing but this all information is there. Hi, my name is Krish, and it says nice to meet you. All this information is there, right? Now what I will do, I will quickly go ahead and write response. Or let me do one thing, because I think it got appended 2 times. Okay, I'll execute this once again. And let's just execute it for one time. Okay, so with this particular thread ID, we will just execute it for one time. And now here you can see that I'm getting one human message, one AI message. Nice to meet you. Now, if I just go ahead and see the last messages, so it'll be messages of -1. So here you can see that if I go ahead and see this particular content, I should be able to see the output. Okay. Hi, nice to meet you, Krish. Is there something I can help you with? Okay. Now let's go ahead and again use the same config, and let me now ask, hey, what is my name? Okay, now let's see whether it will be able to remember or not, because we have already used memory saver, and it is putting everything in that memory saver itself, right? So the previous interaction context where it will be able to remember it. Hey, what is my name? Okay, so I'm just going to go ahead and do this, and we are going to print this particular output. Okay, so we are going to print this output, and remember we are giving the same config. Okay. See, when you create an end-to-end application, this dynamic, ID, thread ID will be maintained in the session itself. So that way we'll be able to maintain this entirely in the memory saver, right? So here now it is able to understand that, hey, your name is Krish. Okay. So this is really nice, right? Now it is able to remember. Do you know what is my name? Uh, hey, do you remember me? I'll just go ahead and write like this. Remember me, right? This is the beginning of us, so I don't have previous memory of you. I have my large language model and all. Okay, do you remember my name? Let's go ahead and ask this question. Do you remember my name? So it will be able to remember me, my name at least. Yes, your name is Krish, right? So it is able to answer that, right? So guys, now we are going to discuss about streaming and Langgraph. See, most of the time, whenever we want to probably invoke or chat with our chatbot, we were basically using this graph.invoke method, right? And somewhere we also use stream, right? Now let's go ahead and try to see like what are the different streaming techniques to probably get the response from the chatbot itself when we're executing a graph. So first of all, what I'm actually going to do is that I will go ahead and implement some of the things, like let's say I will go ahead and initialize my memory saver. Okay. Now inside this memory saver, we are basically just creating a memory object. I will go ahead and create one node definition, and this node is nothing but the name is superbot. And here we are going to use LLM with tool.invoke. Okay. Or I can just go ahead and use LLM, right? I'll just create a simple graph to probably show you what are the different types of streaming that is available over here, right? Now let's go ahead and execute this. Now here is my entire chatbot node that is available over here, right? Now I will just go ahead and create my entire graph. So let's say this is a very simple graph wherein I am trying to create a node called a superbot. The functionality is nothing but superbot. Here from start to superbot, superbot to end, and then we are compiling it with a checkpointer memory, right? And this is how my graph looks like. Very simple graph. I think we are learning a lot, right? Out over here from that much time. Like in this entire session, we have understood how to create different types of graph. Now what I will do, I will go ahead and create a thread. Let's say the thread is 1. I'll say, hey, my name is Krish and I like cricket, and I will give this particular config, and I'm just going to go ahead and invoke it. Okay. Now, when we are invoking it, you can see there are some information that you are seeing, right? One is human message, one is the AI message. AI message is basically the response. Now, with respect to this, we are going to learn about some streaming techniques. Okay. And this will be very handful when you try to develop some kind of chatbot. Okay. So inside the streaming, you have dot stream method and stream method. That methods are sync and async method for streaming back results. And inside the stream and stream method, you have these two parameters. One is value, okay, and one is nothing but updates. Now the question rises, what exactly is the difference between values and updates? So in order to make you understand, let me go back over here. Okay. Let's say I have a, and this is related to streaming, right? In order to make you understand what is the differences between value and updates, that is what we are going to discuss. Okay. So let's say this is my streaming, right? Streaming topic. So first of all, let's say I have this graph. Inside this graph, I have various nodes. Let's say I have node 1. I have node 1. I have node 2 that gets executed. And then finally, I have node 3. And the flow of execution is in this direction, right? And we are discussing about stream and stream methods. There is a stream method, then there is an stream method. In order to understand the difference between stream and stream, this is like specifically used for async. Okay. Now, if you know Python, I think you should get an idea about what is sync and async basically means, right? But the main important point that I'm really interested in is understanding about modes. So inside this method, you have two modes. One is update mode and one is value mode. Okay. One is value mode. Okay. Now, what is the difference between update mode and value mode? And we will play with this parameter. Okay. This is an additional parameter we give. Let's say over here in node 1, as soon as the node 1 gets executed, here my messages variable will be equal to, let's say, hi. Let's say my LLM gives a hi message when node 1 is executed. When node 2 is executed, the messages will probably have another information like my name is. Okay. So this will be my another information. And when node 3 executes it, my current message that is being getting updated, okay, is nothing but Krish. So this is a very simple thing. When node 1 gets executed, my current output response is hi. Then node 2 gets executed, my current response is my name is. And when node 3 is getting executed, it is nothing but Krish. Okay. Now, if I use mode is equal to update, only the message that is currently getting updated, only that message will get displayed as an output. Okay. Let's say if node 1 is getting executed, if I just go ahead and print or do the streaming with respect to mode is equal to update, only this message will get updated, right? Let's say after executing all these 3 nodes, This is the message that is getting executed. Again, I go ahead and give my another input. Then this message will get generated. Then this message will get generated. Whereas in the case of values, in the first case, I will get a message as hi. Okay. But when again I give the message, this message is equal to hi will also get appended, and it will come as my name is in the form of list, right? So this is basically getting appended over here, right? When I try to stream with the help of mode is equal to value. Similarly, when I go to again I give an input and execute all the specific nodes, then here you'll be able to see that I'll get another message which will say, hi, my name is Krish, right? So this is how it gets executed, right? Here, in a specific execution, what is one of the messages that gets appended or that gets displayed, that only I will be able to see it. Okay, so that is a basic difference between mode is equal to update and value. But if you still have confusion, we'll try to understand this with an example over here. Okay, so now what I'm actually going to specifically do is that now you can see over here that I have this. Okay, my name is this and all. Okay, now what I will do, I will use the stream or stream method, whichever method you specifically want, we can use this. Okay, so let's say that I go ahead and create a thread, and this particular thread has for chunk in graph builder dot stream, and I'm giving this message. My name is Krish and I like cricket. I've given this particular config, that is nothing but with thread, and this time I've used stream mode is equal to updates. Okay, so there are two stream mode. One is updates and one is values. Now with respect to updates, if I just go ahead and print it, okay, now see what will be the output that I'll get. Okay, so it shows that what is the current execution AI message, that is what I'm actually getting. I did not get the human message. See, focus in this. Whichever was the last message which came from the AI, only that is getting displayed. But if I just go ahead and execute the same thing, instead of writing mode is equal to updates, I will go ahead and write mode is equal to values. If I execute it, here you can see human message. Here also you can see 2 times human message has got appended. And if you go forward, your AI message will also get appended over here. See, AI message, right? So all the conversation is basically getting updated, right? When you, whether you give an input, whatever output you get here, specifically output you're getting. Okay, here specifically output you're actually getting, right? Again, let me repeat this. Over here, you'll be able to see that whatever output you get after any node, and if you try to stream it, only that is basically getting displayed. This is the AI message over here. Whereas in the case of mode is equal to value, everything is getting displayed. Your human message, your AI message, everything is getting displayed. So that is the basic difference between this modes and values. Okay. So now I hope you get this clear understanding. Okay. And let's say that I go ahead and add one more message. Okay. I'll say, hey, see, I executed this 2 times, right? This is the first time. This is my human message, and here also I got the AI message, and everything is basically getting updated. Let's say I go ahead and add one more method, or I just go ahead and create one new key. Okay. Okay. So let's create this. Okay, and you'll be able to understand this very clearly. So here I will just go ahead and use thread is equal to 4. Okay. I'll say, hi, my name is Krish. I like cricket. Okay, let's start from fresh. So here now mode is equal to update. Now I will be getting the AI message over here, obviously, since I've used this. So I've got the AI message. Now again, I will go ahead and use another message over here. And I'll say, I also like football. Okay. Now see, what will happen if I make this updates to values. Okay. Now see, if I go ahead and print the chunk, I'm getting the human message. My name is Krish. I like cricket. So this is saved in the memory. My next prompt will be something related to I also like football. You can see this. Okay. So let this get printed. It is still executing. So right now I got this human message. In the next sentence, the previous conversation has also got attached, right? Previous conversation has also got attached. And then probably after some time when this gets executed, you'll be able to see that one more message will get appended, and that is related to human message. See, my name is Krish. I like cricket, the previous one. Along with that, hi Krish, nice to meet you. So you also like cricket. Which team do you support? He's asked the question. And if you go forward, here you can see AI message, a sport fan with diverse effect. Now see, here somewhere human message, I also like football has got added. And here you got the response. So values, what it is doing is that it is keep on adding all the conversation inside this, and then you're able to stream through that entire information. Sometimes this becomes very good in use cases where you are focused on understanding about things and all, right? And if you want some more detailed information and all. Now there is one more method which is called as a stream methods. Okay, and for this you just need to probably go ahead and use like this. See, I'm using another thread ID. Let's say thread ID will be 5. Here we are using graphbuilder.stream events, and here you can use the config version, each and every information. If you just print this particular event, no more detailed information on different things, different events. So there are multiple events that are present over there, right? So if you want much more detailed information just to do the debugging and all with respect to every sentences, you can specifically use this streaming technique, right? So now guys, we are going to discuss about a new topic in Langgraph, which is called as human in the loop. Now, human in the loop can also be called as human feedback. In order to explain you, let's make sure to take an example, okay? So let's say that I have a specific example. Let's say I will just go ahead and draw one of the, the same thing that what we are specifically doing, right? Let's consider that here. I have the start node. Then I have one more node. Let's say this is my LLM tool. This is my tool node. And finally, this is my end node. Okay. Now here we know that, let's say that here we have this start. Okay. So this is start. Let's say this is my chatbot. This chatbot has been binded with multiple tools. This is my tool node. When I am creating various tools, and we created one tool such as Tavily, right? We use Tavily. Let's say along with Tavily, we will go ahead and create one more custom tool, and this tool is related to human assistance. Human assistance. That basically means whenever I try to give an input, let's say this is my input. When it goes to this chatbot, which is binded with LLMs, with multiple tools, where we have LLM binded with multiple tools. So here we have LLM with tools. So based on this input, if this makes a specific tool call, and in this tool call, instead of making a call to the Tavily, if it makes a call to the human assistance, okay. Now in response, the human assistant should provide some kind of feedback, and then the chatbot should continue the execution. Okay. So this is what we will try to execute it, and this feedback can be very much necessary. We will take a very good example. Let's say if there is some complex workflow, and in that particular workflow, unless and until a human do not approve, that workflow should not be completed, right? Let's say there are two nodes. One node is executing. Here we can interrupt. With a human feedback. If the human gives a good feedback saying that yes or continue, it should go ahead with the execution. Okay. So let's take this example and show it to you so that you get a clear understanding. So first of all, I've created a new file. Okay. So here you can see that this is very simple. We are just loading the model, which we have already discussed. Here you can see we are using Tavily search, tool, type deck, memory saver, state graph, start end. Add messages is all about your reducers, tool condition, tool node. This is the two new libraries that we are going to specifically use. Okay, one is command and one is interrupt. Interrupt basically means we are interrupting a workflow. It is forcefully interrupting so that a human can provide a feedback. Okay, so here is my state. Here I have used annotated with list and add messages. We have initialized the state graph. Here we have also imported one tool library. This tool library is useful because here we will define a function and that function gets converted to a tool. And this tool can be binded with the LLM. So here we are defining a tool which is called as human assistance. It takes a string and returns a string. Here you can see a doc string is given, request assistance from a human. Human response interrupt query with this. So here we are interrupting with query. Query is equal to query. So whatever query we pass over here, that query it will get interrupted. And then we are returning human response of data. So human response of data, here we are returning that information. Then this is my another tool. So we are combining those tools in the list. We are binding them, right? And here is my entire chatbot. So this chatbot is nothing but it is LLM with tools.invoke, and it is returning that messages. And we are creating this chatbot. We are adding additional condition along with the tool conditions and all, right? So if I just go ahead and execute it, and here we are applying the memory saver. And finally, this is the graph it looks like, right? So start chatbot. Inside the tools, there are two tools. One is the Tavily and one is the human assistance. Okay. Interrupt one, right? So interrupt one, you can also see over here. Uh, uh, if you see, right, this interrupt will happen in the tool node, right? In the tool node, because the tools is having that human assistance. Now let's go ahead with the first question. So first question over here is that user input says, it is giving an input. I need some expert guidance for building AI agents. Could you request assistance for me? Now, this assistance will play a very important role, right? Because here we are providing a message, and this message is matching to this particular doc string. So when LLM gets that message, it is going to call this specific tool instead of calling Tavily. Okay. So now let's go ahead and see. Here we are creating a thread ID. We are giving a user input with stream mode is equal to values, each and everything, and we are executing this. Okay. So here you can see a tool call is made. Initially it went to Tavily search. Okay. But it is not able to provide you the answer. Tavily search says that expert guidance for building AI agent. Now, based on the result of the tool, I can see that it provides two relevant results, a blog post and a YouTube post. So what it has done is that uh, for the first time when we call this particular function, it is calling the Tavily search API. So let's call this again. Okay, I need some expert guidance and assistance. I will change the message. Now see what will happen for building AI agents. Could you please provide assistance to me? Okay. So now we are again executing. I need some expert guidance and assistance. You can see the tool call of human assistance has actually made. So this time, when I just change the message over here in the user input, I need some expert guidance and assistance for building AI agent. You can see that a tool call is basically made. Okay. Now, with respect to the human, because now it has stopped over there. Now it is expecting human should provide some kind of input back, right? So with respect to this, you can see over here now human response, we have provided this. We, the experts, are here to help you out. We recommend you checking out Langgraph to build your agent. It's much more reliable and extensible than simple autonomous agent. So this is the message the human is basically giving. Now, how do we go ahead and execute this message? We basically use this command. You remember in the top, we use this command, and we are going to put this resume is equal to data of human response. So whatever human response we are creating, we are putting in this particular value, and we are telling resume the flow of the execution. And now when we go ahead and resume it, here in graph.stream, we give this particular human command, and automatically you'll be able to see that the execution will happen. Now, human assistant, we the experts, we are getting, and then here you got the AI message. Thank you for recommendation. Langgraph seems like a great tool for building AI agents. I'll make sure to keep that in mind. To further assist, I'd like to ask a follow-up question. What specific these things and all? Now, what you can do, again, now it has again interrupted, right? Sorry, it is not interrupted. Now it is basically giving you as an AI message. Please let me know and I'll do my best to provide your tailored guidance assistance. Now, what you can do is that, again, you can go ahead and put an interruption, and again, you can go ahead and provide a response. So when you are probably creating an end-to-end chatbot, any number of time you can provide this kind of human feedback in the loop, right? So I hope you have understood this topic very much clearly. Hello guys. So in this video, we are going to discuss about how you can build your own MCP servers. Along with that, you'll also be seeing that how you can integrate any kind of MCP servers that you build along with your app. So here is one basic diagram. Here you can see there are three main components. One is MCP servers, MCP client, and app. Whenever I talk about MCP servers, here you can have multiple tools. Just imagine that there is a other company, third-party companies which are developing this kind of services. It can be simple mathematical, calculations. It can be third-party APIs integrations. Anything it can be specifically written over here. Here, with respect to this MCP server, it provides you context, tools, and prompts to the client. And similarly, you have something called as MCP client. Here, the client maintains one-to-one connection with the server inside the host app. And finally, you also have an app. It can be a cloudy desktop, or it can be any kind of app that you are specifically developing. So in this video, what I am actually going to show you is that how we can go ahead and develop this entirely, and how we can also build MCP server from basics and from scratch. Okay. So first of all, what we are basically going to do is that we will be having this application. Let's say that this is the application that I am currently building. Okay. Inside this application, we are going to use LangChain or LangGraph. Okay, application. We will be having some kind of chatbot application in short. Okay. Now this chatbot application may have different LLM integrated in this. So whenever a user provides any input, okay. So let's say a user provides any input. So based on this particular input, the LLM should be able to make a decision whether it has to make any kind of call from an MCP server. Okay. And let's say that this MCP server has some of the important tools. Let's say we have tools like addition, multiplication. I'm just showing this as an example. And let's say that we also go ahead and create one more tool here, um, which is just like a weather call API. Okay, weather call API. Now here you will be able to see that this is my MCP server itself, and this MCP server is connected to this tools which are like add, multiplication, weather call APIs, anything as such. So let's say if I go ahead and ask a question, hey, what is the weather of New York or Bangalore? So the LLM obviously will not be able to answer, because obviously LLM do not have live information. So what this will do is that it will make a tool call, and this time the tool call will be with the help of MCP protocol. Here internally there will be a client that will be developed, which is called as MCP client. Okay. And then once this communication is made, then that specific uh, API tools, whichever based on the input, will be called, and you finally get a response. Okay. So if I talk about like how this entire communication basically happens, first of all, when we get the input, right, direct the call will go to the MCP server. The MCP server will give you all the necessary tools along with what all information it has regarding that particular tool. Then the LLM will make a decision. Then the LLM takes this particular input and passes it to the MCP server to get the response. So this is a basic kind of communication that actually happens, and I have already covered in depth already in my MCP module itself, right? Um, in my previous videos. So this is how the basic communication basically happens, right? Now here, what we are going to focus on is that I will show you how you can go ahead and create your MCP server from scratch. Okay, here we are going to use one of the most popular library, which is called as LangChain. And in LangChain, there is a library which is called as LangChain adapters. Okay, so that we will be going to use. Second, I will show you how you can go ahead and create your MCP client. And whenever we talk about MCP protocol, or whenever we talk about communication with the MCP servers, there are different transport protocol that we use. Okay, transport protocol that we use. Now, some of the transport protocol, um, there are some kind of arguments which actually helps you to communicate with any kind of tools itself. So one of the tool that we are going to use is something called as STDIO. And the other tool that we are basically going to use is related to HTTP protocol. Okay. So we'll try to understand what are the differences between them, and we'll try to also use them. Again, from coding point of view, I'll show you how this also works. Okay. We will be developing our MCP server. We'll also be developing our MCP client. In this MCP server, when I talk with respect to the tools, this tool, one of the tool, we will try to run it with the help of transport protocol, that is STDIO. And the other one, we will try to use HTTP. Okay. And we'll also talk about the differences, what exactly both this transport mechanism, how does it vary, So now let me quickly go ahead and let me open, and this we are going to completely start from scratch. So first of all, I am inside my drive. Okay, so this is the MCP demo LangChain. So here you can see, I will open my cursor ID. I hope everybody has the cursor ID now. Okay. Now from this cursor ID, what I am actually going to do is that I'm going to go ahead and open this particular folder location as my project. Okay. So here I will go ahead and give this particular path, and I will select the folder. Okay. Now, the first step when you're specifically using cursor or whenever you work in any kind of projects, it is good that you try to create a environment. Right now, before creating an environment, I need to initialize this particular workspace as a with the help of the UV package. Okay, so if you know about UV, it is quite faster. You'll be able to probably do the development very much fast with respect to the package management of the entire project itself, right? Any Python project. So let's say that I'm going to go ahead and initialize this workspace with the help of UV package. So I'll write UV in it. So this is the first step. Now here you can see, based on this, there are some files that has been already created. Okay, and if I talk with respect to all the specific files that we have created, over here, one very important thing is that you have to go ahead and see which Python version this entire the basic package is basically created with. So here you can see Python version is 3.13. Here you have this pyproject.2ml. So right now the dependency is empty because we have not installed any kind of dependencies right now, right? But we will go ahead and install it, right? And this is the basic project information. Now, to start with any project, I will go ahead and create my virtual environment. In order to create the virtual environment with the help of UV, it is very simple. So I will go ahead and write UV VNV. Okay. Now here it shows that, okay, my VNV environment has got created. Now any packages that I install, I have to install inside this. So first of all, I will go ahead and activate my environment. In order to activate, I will just go ahead and copy this command and paste it over here. Okay. So now we have activated my environment itself. Okay. Now this is done. Now the next step is that we go ahead and install some of the packages. Okay. Now we will see how to install the packages. But before that, I will just go ahead and create my requirement.txt. Requirement.txt. Okay. Now with respect to requirement.txt, I will just go ahead and write what all libraries I will be requiring. Okay. So two libraries that I specifically want to use. One is LangChain Grok, and then you also have something like LangChain adapters, right? So as I said, we are going to go ahead and use um, some of the libraries that are available with respect to this, that is LangChain adapters. And with the help of LangChain adapters, you will definitely be able to use this MCP properties even in LangChain. Okay. So here you can see I will write LangChain MCP adapters. Sorry, it is MCP adapters. And along with this, I'm also going to use one library which is called as fast MCP. Fast MCP. Okay. So here with respect to fast MCP, you can actually see this, what exactly this is. Okay. So let me just go ahead and search for fast MCP again. So if I talk about fast MCP, here you can see it is the fast Pythonic, it is written something like Pythonic way to build MCP server and client. Okay. So we are going to specifically use this. This is a very easy way of creating MCP tools and all. So definitely I will show you step by step how you can basically use this fast MCP library and develop your entire MCP servers from scratch. Okay. Step by step, we will go ahead and implement it. Now quickly, here we are going to create three more important files. Okay. Now what all files needs to be created based on this, that is what I'm going to discuss. And understand based on the use cases, right? I've already told you that I'm going to use one MCP server which has this add multiplication, and we'll use the transport as studio. And we'll create another MCP server which will be communicating to this tool that is called as weather call API, and it will use this HTTP tool, right? Transport mechanism. Okay. Transport mechanism basically means the communication between the client and the MCP server, how it is basically going to happen. Okay. And so what we are basically going to do is that over here, I will just go ahead and write all my packages that is specifically required. Okay. And along with this, I will also go ahead and import MCP. Okay. So this MCP will actually help us to use the package fast MCP itself. Okay. Now here is my requirement.txt. The next step is that how do I go ahead and install all these particular libraries? It is very simple. I will go ahead and write uv add -r requirement.txt, like how we used to write pip install requirement.txt. Similarly, we'll go ahead and do this. Okay. So now I'm going to go ahead and clear the screen, and just to confirm whether all the installation has happened or not. So here you can basically go ahead and check out all the installation with respect to this. Okay. Till here, everything looks good. Our installation has happened perfectly, and we have already installed all the packages that is required. Okay. Now, let me just go ahead and create some important tools, right, with respect to the MCP server. So first tool that I'm actually going to create, it's nothing but math server. Okay. So math server.py. So this is just like my MCP server. And here we are going to define some of the tools that we are basically going to use. Okay. So quickly, in order to use this, as I said, I'm going to use fast MCP. So I'll write from MCP dot server dot fast MCP. I'm going to go ahead and import fast MCP. Okay. And once we do this, the next step is that we need to initialize this MCP, right? So I'll go ahead and write MCP is equal to fast MCP, and I will give my tool name, which is nothing but math. Okay. So I'll give my tool name, which is nothing but math. Okay. Now, inside this tool, inside this server, this is just a server name, okay, not tool name, because math is just a basic server name over here. Then the next step is that I will just go ahead and write @mcp.tool. And this is how we go ahead and create our first tool, which is present inside this MCP server. So I'll create a definition. I'll write add. I'm just starting with a basic example so that, see, sky's the limit, as we say, right? You want to go ahead and create any kind of tool, but it is important that you understand from basic stuffs, right? So then my second parameter will be is equal to int. And this I'm going to return it in the form of integer. Here, I'm going to probably provide some docstring. And based on this docstring, the LLM will be able to understand which tool to specifically call. So here I will write add two numbers. Okay. And then we are going to go ahead and return a plus b. Okay. Then the next tool is nothing but mcp.tool. And here we are going to go ahead and define multiply a colon int comma b colon int. Again, you can go ahead and define any number of tools as you want. So this will return a int type. And here I'll just go ahead and write multiply two numbers. Okay. Some information that I'm specifically giving. And I'll go ahead and write return a multiplied by b. Okay. Now, the thing is that, see, I am planning to create this MCP server with respect to this addition, multiplication, or any kind of tool on the transport stdio. Now we need to understand what this stdio transport basically means. Okay. And what you will be able to do from it. And it is important that we get a clear understanding about that, because many people have seen that they try to write this particular code, but they fail to explain this. Okay. What does mcp.run, so let's say that I want to run this particular file. How do I go ahead and run this? First of all, I'll go ahead and write the code. So quickly I will write mcp.run. So here what I'm actually going to do, I'll just say if underscore name underscore double equal to underscore main underscore, and here I will just go ahead and write mcp.run, and we are going to run this entire application of MCP using the transport double equal to stdio. Okay. Now here we have used a transport called as stdio. Now we need to understand what this transport is, and for this I will just go ahead and put some basic information so that you should be able to read it within the material itself. Okay. So here I will write two important comments. The transport is equal to stdio, and here one more sentence. See, it tells the server to use standard input output to receive and respond to the tool functional calls. Now see what this is, right? When we say input output, right, the standard input output, the standard input output is like, let's say if this is a server, if it is running, this will specifically run in some kind of command prompt. Let's say in one of the scenario, what we can do is that if I have a client and I want that client to interact with this particular server, then what we'll do, if we have written this transport is equal to stdio, we will run this particular file directly in the command prompt and get the input and the output there itself. Like let's say if I want to probably give an input, that input should go with respect to the command line itself, hit any function and get the response out there. and the client should be able to read the information out directly from the uh, HTTP out. That basically means from the command prompt itself, right? So this kind of thing is very helpful if you really want to test out things locally. You have your server executed in the locally itself, and you really want to go ahead and test it with the client, right? So at that point of time, you can use HTTP. Okay. So this is the basic functionality with respect to this. So this is one of the server that we have basically created. The another server that I am really interested in creating is about, let's say there may be a third party API call. That API call can be with respect to weather, it can be anything as such. But just to show it to you, I will quickly go ahead and create one weather.py file. Okay. Now weather.py file, see, now at the end of the day, I'll also talk about like how do you probably take it to the production and what exactly goes into the production also. I'll not show you directly by executing this in the cloud, but I'll give you a brief idea like how things works over here, right? So here I will go ahead and write from mcp.server.fastmcp import fastmcp. Okay. And then I'm going to go ahead and write mcp is equal to fastmcp, and this time this particular server name will be my weather. Okay. Now here I'm going to go ahead and create my MCP tool. Okay. Now, in a real world scenario, if I talk about that this is my MCP server and I want to probably take an input and give the weather of a specific location, that is the code that I'm going to write it over here. Okay. But for right now, I'll just going and defining something. So I'll go ahead and write, hey, this is my get weather functionality. And let's say this is my location. Okay. This is my location, this is my str, and this will basically return a str. Okay. And then what I will do, I will go ahead and write my doc string get the weather location. Okay. Weather location. Now this can be any code. This can be a code which will be interacting with some kind of third party API and getting the weather, right? For right now, I'll just return some constant value. So let's say here I'll write it's always rainy. It's always raining in California. Let's say I'll just go ahead and write this message. Okay. It may not be a true weather, but I just want to give you an idea. Let's say that this is the output of my API that I'm getting. Here you can write any code with respect to interacting with some kind of APIs. And then I will go ahead and write if underscore name underscore main underscore, right? So here my program execution will basically start. This should be double equal to, okay. Now what I will do, I will quickly write mcp.run, and this time I'm going to use another transport. See, whenever I want something, see, before the one transport mechanism that we have specifically used is nothing but stdio, right? Stdio, I have told you the importance of it. In this, we are going to use streamable HTTP, right? HTTP. Now you need to understand what this exactly means. Okay. So guys, now let's understand what this transport streamable HTTP will do. Okay. Now here, in order to make you understand what exactly the functionality is, right? So I'll just go ahead and open my terminal. Now inside my terminal, what I will do, I will just go ahead and run this. See, Python weather.py. Let's run this. Okay. Now here you can see that this entire application, this entire server is running in this particular URL. Okay. When we use streamable HTTP transport, what it is going to do is that it is going to run as an API service itself. Okay. Similarly, if I go ahead and run this math server, right, in stdio, it will not run like that. See, here it will not run like that. Instead, it will try to get, it will not run in any kind of HTTP protocol, but instead it uses standard input and output. Okay. So if I just go ahead and execute this Python math server.py, here you can see that nothing is happening, right? So that basically means internally, as in the command prompt, it is getting executed. Okay. But if I see in this particular use case, when we are using weather.py with the help of transport is equal to streamable HTTP, here you can see that it is working, it is running as in the form of an API with this particular URL. So here after this transport, you can also go ahead and set up your URL and all. And with respect to that, you can also set up the port. Okay. But right now we are not running this. We are running this as an HTTP, right? So by default, you will be able to see it is taking my local host and the default port is 8000. Now the question rises, Krish, Fine. You told me the differences between streamable HTTP and obviously HTTP, where my transport was HTTP out, right? So here I have used HTTP IO, right? So you have told the differences between them. But how do we go ahead and integrate it from the client end? So here what I will do, I'll go ahead and write client.py. So see, I have created two servers. One is the math server and one is the weather server. Now it's time that we go ahead and write our client.py file. So let this things get running. Now I'm going to go ahead and focus on understanding that how do you go ahead and write the client.py. At the end of the day, this client.py should be able to interact with mathserver.py and weather.py. So for this, I'll be using from langchain underscore MCP adapters dot client. So we have to first of all go ahead and create a client, and this client should be, according to the documentation that is given from the Langgraph, it should be a multi-server MCP client. Okay, that basically means supports multi-server itself. Then in Langgraph, whenever I want to probably call any of this particular client, we need to create an agent. That agent will be responsible in integrating all these particular models, LLM models or tools. Tools basically means all these MCP tools and all, right? So for this, we will be using pre-built. So from Langgraph dot pre-built. So first of all, I will just go ahead and quickly add Langgraph also, because I require Langgraph. Okay. So here I'll open my command prompt, another command prompt, and I'll write, hey, uv add -r requirement.txt. Okay. So this is perfect. And then you'll be able to see that if I just go back to my client.py, now I will be able to import it. So from Langgraph.prebuild, create React agent. So for creating an agent, so that based on the input, the agent, the LLM will be able to act an agent itself. And in my previous videos, I've all discussed about this. If you're following the series of videos that we have developed, right? Then from langchain underscore grok, import Chatgrok. So I'm going to go ahead and use Chatgrok also. And then from langchain underscore OpenAI will not going to use. So from langchain underscore core, I'm also going to go ahead and use, or let's say for right now, I will just go ahead and use like this, from .env import load underscore .env, and then I'll go ahead and initialize this load underscore .env, and then I will also import async IO, right? Now the next thing is that I definitely require my .env file. So quickly, let me go ahead and create my .env file. This is just for my LLM model, right? So I'll write grok API key, since I'm going to use grok API key. Now I hope everybody, if you're following all the tutorials that I've created till now, you should know how to create a grok API key, right? So here is my grok API key. I'll go back to my client. And inside this particular client, I'll start going and writing my content, right? My code, sorry. Now, what I'm going to do, I'll go ahead and write async definition main, okay? And here we are basically going to go ahead and create our client. This client that we are going to create will be my multi-server HTTP client, sorry, MCP client. And here I will give the client key value pairs, right? So the first client that I want to create, so first server that I want to create, right? So this client will be able to interact with this MCP server. So it will be my math server. In the math server, let's say the command that I want to use in order to execute my math server will be nothing but Python, because you can use Python or UV, it is up to you. Okay, Python. And then the next parameter that we give is argument. Okay, let's see a lot of suggestion that comes in this, right? So arguments. So inside the arguments, I will give my another parameter, and that parameter will be nothing but it will be my file name. So here I'm going to go ahead and write mathserver.py. Please make sure to give the right location. So here, since this is my current working directory, I'm directly giving the name of the file. If it is inside any folder, I have to give the entire relative path. Okay. So once this is done, sorry, not relative path, absolute path. So here I'll go ahead and write the comment, ensure correct absolute path. Okay. Then my next parameter over here is nothing but my transport protocol, like my transport metrics that we really want to give. So here, based on the transport that we have used, what transport we will be using? It is nothing but stdio. Okay. So here I will go ahead and write stdio. Okay. So this actually completes all our parameter with respect to maths. Now similarly, I will go ahead and add my another tool. So this is my maths tool over here. Okay, I'll go ahead and write it like this. Now coming to the next tool, it is nothing but my weather tool. So if you see my weather tool, it will be something like this. Weather localhost 8000 slash MCP ensure server is running here. So if you see over here, my server, it is running where? It is running in this local host, and when I do slash MCP, that basically means it will be able to get all the MCP servers that it is running. All sorry, this particular weather where it is specifically running in this particular URL, right? So here, obviously, my local host is there, but if you see slash MCP, this is where we will be able to find the entire MCP running. Okay, so this will be my URL over here, right? So now till here, it is really, really good. Easy itself. Here we have just created our multi-server client. Now remember this client is what will be interacting with this particular servers, right? So now I will go ahead and quickly write import OS, and then I will go ahead and set up my environment. So os.environment, it will be nothing but grok underscore API underscore key. And here I will just write os.getEnv with my grok API underscore key. Okay. Then I'll go ahead and write my tools. It will be await. First of all, in order to get the tools, I can use client.get underscore tools. Okay. Now see, this client is nothing but this client, right? And when we write dot get tools, I will be getting the information of both these tools like math and weather, right? Then I will go ahead and initialize my model. My model is equal to chat grok. And I'm going to go ahead and use a model name, which is nothing but Qwen QWQ 32 billion parameter. Okay. Then I will go ahead and create my agent, and this agent will be create React agent. And here I'm going to go ahead and write model, comma tools, right? So this is the two important parameter that we need to give in order to make the agent. Now I can use this agent and directly call, invoke with respect to any messages that we specifically give. So let's say if I just go ahead and execute this math underscore response. So here you can see I'm just executing this. Just a second. So import OS, this is done. Okay, now math underscore response await agent.invoke. I'm giving them messages is equal to role with user content. I've just written what is 3 multiplied by 5 multiplied by 2. Okay, 3 plus 5 multiplied by 2. And here I should be able to print my response. Print my response. So here in order to print my response, I will write, hey, maths response colon. Okay, math response is equal to, I'll just go ahead and give this, and then I'll write math underscore response. I will take the messages key. I will take the last message that is available out there, and I will go ahead and read the content. Okay, dot content will give the output of the maths response. Okay, now since this main function is async, so in order to run this, we are basically going to use async io dot rain. Okay, and here we are going to call the main function. Okay, so whenever we use async io, whenever we define any method that is async, we have to go ahead and run this with this particular library which we have imported it over here. Okay, so here we are just trying to get the maths response. Okay, now let's go ahead and execute this. I will go ahead and open my command prompt. Now understand very important thing. When I'm calling this agent, right, it is invoking which tool? Based on this particular message, it will invoke this tool. And you know, in this tool, the transport is stdio. That basically means this tool is going to run in the normal standard IO device, standard input and output device, that is nothing but command line. So that the input will directly go over there and get the output from there. Okay. So here in order to execute this, if I go ahead and write Python client.py, okay. Now you should be able to see, I'll cancel this. You should be able to see what will be the output for this. What's 3 plus 5 multiplied by 12? Okay. So this is my input. Now you should be able to see what will be the output. Here's the step-by-step breakdown. Addition 3 plus 5 is equal to 8. Multiplication 8 multiplied by 12 is equal to 19. Maths response is nothing but the result of 3 plus 5 multiplied by 12 is 96. So 8 multiplied by 12, it is nothing but 96. This is absolutely perfectly fine. Okay. So here you can quickly see that how we are able to call our MCP server And that is nothing but our math server, which is running in this stdio, right? Now the other thing is that if I also want to check the weather server, right? So for the weather server, again, I will go ahead and write like something like this. See, I'll give a question quickly, and it will be the same thing. See, weather response await agent.invoke content. What is the weather in NYC or California, right? California. Now this, it will take this particular message, but right now I have hard coded the output. It always rains, and it is always raining in California, right? We have written like this. So my weather response should probably come the same thing what we are getting directly from the weather.py. Okay. So I will go ahead and run this once again. And before running this, I will also go ahead and print the output. Okay. So this is my weather response. Yeah, it is printed. So now if I just go ahead and execute this again, Python client.py, first of all, I should be getting my maths response. And the second thing is that I should be getting my weather response. Okay. So quickly, let's see this. And this is how you're basically communicating from one client to multiple servers itself, right? So it is taking some amount of time. Okay. See, at sometimes, sometimes this kind of errors will come. You just need to go ahead and restart it. Okay. But now this kind of error will not come. Okay. So now you'll be able to see that. It will do the execution. So here you can see the result of 3 plus 5. Weather response, the tool indicated it is always raining in California, but in reality, California has a diverse climate. So LLM is also able to add some information, which is good. But here, now the tool is basically returning this, okay? So that is the reason. Again, it depends on what kind of API functionality you're implementing it. The best part is that this is running in a streamable HTTP. So like it's running in the form of in some URL. You can just see that, and we are integrating that in client.py, right? And this is the URL that we are getting it with /MCP, right? And all these things with the help of LangChain adapter, right? So I hope you are able to understand this particular example. Now what you can do is that you can close all the servers with what you're running, but these are some servers that are independently running and you're integrating them in a single client. Okay. So these were two ways of calling. One is stdio transport and streamable HTTP transport. So here we have created a client. So in short, what all things we did. So we created a client, and this client were able to communicate with two MCP servers. Okay. So this communication was basically happening. This MCP server, it is basically communicating with your transport equal to stdio, and this MCP server you are able to communicate with HTTP protocol, transport protocol. And here, see, this entire thing is basically set up with MCP protocol itself. So we had that MCP server client, right? In this, you had some tools like math, addition, subtraction, whatever tool you want to create. And this was like a weather API, right? The main thing is that when you're running this tool, you are basically communicating with respect to the response from the stdio itself. That basically means from the command prompt. Here, we were using some kind of URL, right? So that is the reason we use HTTP. So I hope you understood this particular video. I hope you understood the coding mechanism that we specifically did, how we implemented each and every step. This was it from my side. I hope you like this particular video. I'll see you on the next video. Thank you. Take care.